This looks like a big expression, but trust me, the solution is very simple. Now to handle this, let's take two numbers at a time and let's understand the behavior of the expression. What I mean by that is, this is 4 power an odd number and this is 9 power an even number. We know 4 power odd number ends with 4 and 9 power an even number ends with 1. Because he said multiply, let us also multiply. So this basically gives us 4 in the unit place. Similarly, this is 4 power an odd number and this is 9 power an even number. Therefore, this also gives us 4. Similarly, this gives us 4 and so on. So this helps me understand that 4 basically comes for 50 times. So I can write this as 4 power 50. Now we know when it is 4 power an even number, we always have 6 in the unit place. Therefore, for the entire expression, 6 is going to be the last digit. This is a similar question, just that he has given us addition here. Now again, this is 4 power an odd number, which is 4 in the unit place, and 9 power an even number, and that is 1 in the unit place. But we need to add it this time, and that is going to give us 5. So it's 5 here, 5 here, and so on. So 5, of course, we are only bothered about what comes in the unit place of a number. So 5 is basically going to come for 50 times. So that's 5 into 50, which is 250, or we have 0 in the unit place. And that's the answer. Okay, if you're not good with the basics of unit digit, I would recommend you to watch the other 2 parts that I've done on unit digit and then come back to this question. But if you think you have already watched it, then let's get into it. The couple of things we need to notice before we deal this question, which is, okay, the first thing here is, no matter whatever is the factorial, which is greater than or equal to 4 factorial, we know it is always divisible by 4. Right? Let's say, for example, if it's 6 factorial, we know 6 factorial will have a 4 in it. And when I divide it by 4, obviously it's divisible. The remainder is 0. Similarly, take any number. Let's take 120 factorial. I am not bothered about the value of 120 factorial. But I know for the fact that when 120 factorial is expanded, I know there is 4 in it. And when I divide it by 4, we know it's divisible. Right? So any factorial that's greater than or equal to 4 factorial, it's divisible by 4. And this is an important point to observe before we get into that question. Now we are ready to attack this question. We know for 8 we depend on its cyclicity, and cyclicity of 8 is 4. Similarly, the cyclicity of 2 is also 4, which is why I am bothered about if the power is divisible by 4 or not. In this case, yes, it is divisible by 4. We have seen how it works. Similarly, it's the same number no matter whatever is the number. As long as it is greater than or equal to 4, we know this number is going to be divisible by 4. Right? So because the number is divisible by 4, we get the remainder as 0. So that gives us the last digit of 8 power n series. Similarly, it's divisible by 4, so the remainder is 0. So this is also the last digit of 2 power n series, right? And this is 6 power any damn number is always 6 in the unit place. And now if you notice this is a different factorial. But we know any factorial that is greater than or equal to 2 factorial is always an even number. So this is basically 9 power an even number. Now if you look at this, we know 8 power n series and the last digit is 6. 2 power an n series, the last digit is 6 again. This is 6 here. And 9 power an even number, this gives us 1. So this is 6 plus 6 plus 1, which is 18 plus 1, 19, or we have 9 in the unit place. Okay, he's asking about remainder. He's not asking about last digit. But yet, the concept of unit digit can be applied to this question because he says, what is the remainder if the number is divided by 5? Now, the beauty of 5 is, if I have to find out the remainder of a particular expression when divided by 5, it's sufficient if we know what comes in the unit place. If you did not understand that, let's deal with the basics. Let's go for simple examples. For example, if it is 13 when I divide it by 5, the remainder is 3. If you notice, it's basically the unit place. Or if you look at, let's say, 297 when divided by 5. Now if you look at the unit place, of course the remainder is not going to be 7, but it's sufficient for me to give a remainder if I look at the unit place, meaning 7 divided by 5, that's 2. So the remainder of this expression is 2. Or if you take a number as 1, 2, 3, 6, 5, 4, 9, right? When I divide it by 5, and if I have to find out the remainder, I need not divide the entire number. I have to just divide the unit place of this number with 5. And that's sufficient for me to give the remainder, which is 4. Right? Now because you understand this concept, so we basically understood I need to find what comes in the unit place of this number. Now because there is 3 in the unit place, cyclicity of 3 is 4. So I need to take the power divided by 4 and find out the remainder. The remainder in this case is 1. Remainder will only help you understand which digit you are supposed to look at in 3 power n series. Now because this is 1 as the remainder, I have to look at the first digit of 3 power n series. And the first digit of 3 power n series is 3. So we understood the unit place of this expression is 3. Now 3 when divided by 5, the remainder is 3, which is our answer. As simple as that.